2012 was an interesting year for Two Suns in the Sky videos. The most stunning are always at sunset and sunrise, because when you're observing objects near the sun, this is when you will see them, before sunset or before sunrise. The result is that we see interesting videos and the Herculean efforts of citizen researchers and journalists to make sense of them. But in the end, it's the same thing as ufology, where 90% of observations are debunked and 10% can never be explained. Hello, I'm Marshall Masters, author of Crossing the Cusp, Surviving the Edgar Cayce Pole Shift, and publisher of Yowza.com, YOWUSA.com, and the Planet X Town Hall. And the reason we can never reach a consensus about these two suns in the sky observation reports is that they all have one single common failing. They're all one-offs. Consequently, no matter how interesting they are, that's all we can say about them, that they're interesting or not. But all that changed for me in late December of 2012 when I learned about a volcano surveillance camera feed coming in from Turrialba Volcano in Costa Rica. I assembled a team drawing on talented folks at the Planet X Town Hall, and everybody jumped in. Our goal was simple. Each day, at least one team member would visit the Volcan feed webpage. However, my first interest was in getting a boots-on-the-ground field report from the same location as the Volcan camera. Unfortunately, Turrialba erupted in 2012 and continues to vent toxic gases, as you will see in this program. Consequently, the Costa Rican government has barred public access to the site. It's locked down. Nonetheless, our team has downloaded hundreds of high-definition images and we've recorded hours of Volcan web page viewing. The result is that this Volcan feed has yielded results that could be a game changer. Consequently, the goal of this program is not to tell you what this object of interest is, but rather to present the information as we found it, so that you can decide for yourself. What you see now is a video capture of the Volcan webpage on January 28th of this year. Given that the images refresh about once every 7 to 10 seconds, it's not much faster than watching paint dry. For this reason, all of the other video sequences in this program have been accelerated by 800% for your viewing convenience. And with that, it is time to introduce our cast of characters, who I've dubbed Matthew, Quigley, Bluebonnet, and Yogi. All of this began for me on December 28, 2012, when I was contacted by a gentleman in Costa Rica. He wishes to remain anonymous, but has been a steadfast and highly productive member of the research team. Given his natural inclination for observing things at a distance, I named him Matthew Quigley, and I'm now going to read excerpts from his initial December 28 contact email as my way of introducing him and important details about this object of interest. Matthew says, "Hello, Marshall. I retired to Costa Rica in 1995 from the United States. I am a former college administrator and part-time professor. And for the past several years, I have seen one of our local volcanoes, Turrialba, spewing smoke and ash. I can see it from my front yard about 10 miles away. About a year or so ago, our local university, the University Nacional in Heredia, Costa Rica, added a webcam on top of the volcano on their earthquake page. If you click on the camera image in the top right of the page, you can see the webcam image that updates every 10 seconds or so. I have been watching this site just about every day. Many days are cloudy and you can't see anything. However, on clear days, you can see the hole and the ash coming out. This is because the camera is pointed west. Recently, the last month or so, I noticed something very strange. There was a second point of light, a second smaller sun, if you will, to the right and slightly below the sun. I thought you might like to see this and see what you think. Well, that certainly was a genuine contact in my book, so I took him up on his offer and made some initial screen captures myself. As we corresponded back and forth over a period of days, I could see that we had imagery that was definitely transcending the 90% hoax rate of ufology, and that it put itself well into that 10% nobody can explain. But maybe a team could, or at least shave the odds. So one thing led to another, and all this resulted in the formation of the research team devoted to an analysis of the Turrialba Volcano Volcan feed. The team consists of Matthew Quigley, our man in Costa Rica, plus Barbara and Ed from the Planet X Town Hall, and myself. For you Town Hall members, Barbara's screen name is Barb and Ed's is Master Q. Each member of the team is responsible for observations and analysis. Matthew is the lead on image capture and the volcano site. Barbara assists with image captures and is the lead on data archival. Ed is the science and astronomy lead and resident debunker. As for me, my job is to do whatever I want, while making as much work as possible for everyone else. On the whole, I believe it works rather well. So, with that, I'd now like to introduce you to the more colorful stars in our production, Bluebonnet and Yogi. I dubbed our object of interest Bluebonnet because it reminds me of the flower, the Texas bluebonnet. Texas bluebonnets start to bloom in late February or early March and then go to full bloom sometime in April. These are beautiful flowers, and knowing they'll all be gone by June always makes them special. When I lived in Texas, I always found time to go sit in a field of bluebonnets when they were in full bloom. You could just say that they pop up one day to take your breath away and then go away the next. This was on my mind when I first began monitoring the Volcan feed. Would this object of interest come and go, or have we yet to see it come into full bloom? That's why I dubbed it Bluebonnet, and of course, Bluebonnet has a sidekick. I named him Yogi, so yes, this is a Ranger Rick story if there ever was one. And as all stories do, it has to start somewhere, and this one begins with Ed, our science lead on the team. The badge-shaped reflection that now appears near the middle of the screen had him stumped. During a conference call, he said it looked like a shoulder patch you would expect to see on the uniform of a park ranger. And as he went on to explain other aspects of his observations, I couldn't help but hear the cartoon character Yogi Bear in the back of my mind saying, "Hey there, Mr. Park Ranger, sir. What's in the picnic basket?" So, what is in the basket? A direct connection between Yogi and Bluebonnet? Or are they merely coincidental? We'll take these questions head on in this program because they were driving factors in our own research efforts. All of this really came to a head on January 21, when Ed, our science lead, posted his initial findings on Bluebonnet, in which he said, "At times, the object appears to be a reflection or refraction. However, there are many redeeming characteristics. 1. The object appears when there is not a light source. 2. When the object appears, It is sharp, with a shadowed side away from the sun. 3. The object does not move with the sun, but moves at a sharp angle to the ecliptic. 4. The light source moves across the sky and the object still appears as intensely. So in summary, Ed's bottom line finding for Bluebonnet was that this is not consistent with the reflection or refraction. The object is an enigma. An enigma? Whoa! Now that reminds me of that classic line from the film Glengarry Glen Ross. First prize is a Cadillac, second prize is a set of steak knives. To me, Ed's enigma finding was like winning a set of steak knives. That just wouldn't do. Besides, I'm a geek, and as we geeks like to say, got enigma? Get data. Thusly invigorated, I immediately made more work for me and everyone else. So was all that worth the effort? You'll soon find out. So let's take a quick look ahead. First, we're going to answer the most important question about this imagery. Why is it different? Then we're going to tackle the question that no doubt is at the front of your mind. Is it real? Then once we've done all this, we'll be ready for the big question. Assuming it is real, where is it going? There's an old Roman adage, many roads lead to the heart of a great mystery, and this is just one of those roads. But this road is going to take you on a path that explains why you would have to be standing above the clouds to see what we were seeing from this Volcan camera feed during the month of January. As researchers, our first question after we have vetted the material is why is it different? As we looked at this volcano feed, we saw three basic differences. They are elevation, persistence, and motion. So let's take a look at the role elevation plays. In 2008, I went on vacation with my lovely wife Yelena to Maui. Midway through the trip, I decided to get up in the middle of the night so I could drive all the way up to the top of Turrialba Volcano to videograph the sunrise. It was a long drive up in the dark, and it would have been nice to have been able to have coffee at the visitor center, but they were not open that early, so I proceeded on to the observation center at nearly 10,000 feet. The observation center faces east, but if you look over your shoulder, you can see the Haleakala Observatory. Now, while it doesn't make sense to schlep a parka all the way to Hawaii, I nonetheless wish I had been a wee bit better prepared, because I wore a heavy sweater and 2 light jackets and was still cold. But oh my, the view was worth it. That's because when you are looking down on the top of clouds from a volcano, you see a completely different universe. Standing above the clouds, you can see more clearly, and more further than any mortal soul ever could, standing beneath the clouds. But likewise, our cameras and video cameras can also see more as well. Not that we would want them to. Nonetheless, this video capture from the footage I shot in Hawaii gives us a good way to peek inside Yogi's picnic basket, and we'll discuss that later on in the program. However, the point that matters now is that Volcan is at around 11,000 feet and the Haleakala Observatory is at around 10,000 feet. The benefit of this elevation is obvious: persistence. For us, we could just keep coming back day after day, weather permitting, and there was our object of interest. The result of that was that we could build some motion studies, and we're going to share those with you now so that you can see how this thing moves. Enjoy. Next, we're going to take a look at the debunking issues that usually come to mind, such as, is this photoshopped? Let's take that one real fast because it's pretty easy. This is a raw feed. It's pumping in 24/7, about 60,000 images a week. Now, how many Pixars and Walt Disneys would it take to Photoshop that much imagery? The numbers kind of blow it away. So no, it's not Photoshopped. And with that, let's move into the more serious debunking issue. Is it real? I first got into this genre back in 1999, and it was around 2005 when I started doing my initial analysis of two suns in the sky cell phone images. What I found for those years, from 2005 to mid-2011, was that virtually all of it was being planted on the internet by paid disinformationalists. There were cranks and trolls and pranksters, but most of it was there to inoculate people against this kind of imagery so they would have a knee-jerk reaction to it. Sundog, 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 kind of like a religious mantra. But then in 2011, something I was looking for started showing up, and I was really happy about that. I was starting to see genuine reports from decent people who wanted to be understood. That was a game changer. So over a year ago, I began collaborating with Richard Shaw of Pinlight Productions in Hollywood, California. Since then, we've been investigating two suns' smartphone observation reports with a focus on camera technology. Like any other research effort, we established a protocol and various evaluation criteria. In the process, we put together a sizable toolkit, and if you like to tinker around the house, you know that there's always going to be that one tool you reach for more often than the rest. For us, that tool of choice became motion studies, similar to the ones you've just seen. In terms of making a determination that an object of interest is a reflection or natural is actually fairly straightforward. If you have motion. If you have motion and not a still, any still can be debunked. But if you have motion, now it's a whole different ball of wax. Because a natural object will move in a natural way. In other words, it moves with a purpose. But if it's some sort of lens aberration, a flare, a reflection, or refraction, you name it, well, it's going to move around like a hoochie-coochie dancer. That's what I call it. In his most recent production, Watchers 5, with L.A. Marzulli, in which I also appear, Richard offers us a very useful lens reflection hoochie-coochie dance simulation, if you will. When you see an interesting video on YouTube, download it. Real Player has a good downloader. There are others that you can get as free add-ons to your browser. After you've downloaded that file, now you can shuttle back and forth through it at anywhere from about 4 to 8 times the normal speed. I found DivX and QuickTime actually work best for that. If you do that, you're really going to see a lot of things that you're not going to see with a still image. And that brings us to a logical debunking question. Is our object of interest the moon? Is Bluebonnet the moon? This is a legitimate question because, as you can clearly see, the moon is in Volcan's field of view. However, if you look up in the upper left-hand corner and note the timestamp, you will also see that this observation is early in the morning. Ergo, the moon will be nowhere near Volcan's field of view in the afternoon. So the answer is no. The point here is before you draw a conclusion on imagery, check it out. Go into its history. The who, what, where, when, why, and how. If you do that, you can save yourself a lot of time, trouble, grief, and in some cases, embarrassment. Now, let's move on to those lens reflections. This was one of the rarest video sequences we captured because it puts Bluebonnet together with all the other observed lens reflections and halos. Remember, motion is what we look for, so as you look at these reflections and halos, see how they move in relationship to each other. Notice the ones that seem to move in response to changes from a light source versus the ones that do not. When you do, you'll see the halos and other reflections doing the hoochie coochie dance in this sequence. But likewise, notice the natural way Bluebonnet seems to be chasing after Yogi, which itself is traveling at a unique pace. The upshot is that Ed's findings are correct. Bluebonnet is not a reflection or a refraction. That's what we've just seen. But on the other hand, what about Yogi and its shape? How did that shape come to be, and what does that say about Bluebonnet? Here we have a really good shot of Yogi on February 1 of this year. We got this one because Barbara knew I was looking for good Yogi images, and so she started scrounging around and hit pay dirt. And she not only got one, but she got two. And despite the difference in light levels, Yogi keeps his shape. So have we seen something like this before? Yes, we did with the sunrise image I captured at the Haleakala Observation Center in Maui in 2008 at an altitude of nearly 10,000 feet. When we trace its outline, we see a repeat of what we have with Yogi. Symmetrical shapes. So what makes them? The lens of an industrial-grade, high-definition, long-range surveillance camera like Volcan in Costa Rica will naturally have a lens diaphragm with blades. It is the blades in the lens diaphragm that create the symmetrical image we see. This, of course, begs the question, could a smartphone camera create the same kind of image? No. A smartphone camera is about 3 to 5 millimeters wide and is consequently too small for a lens diaphragm mechanism. This is why smartphone cameras use shutter speed to control exposure, and they have shutter speeds of up to 1/10,000th of a second. So one could say that Yogi's reflection is a kind of quality seal for the Volcan feed. However, there is one last nagging issue with Yogi. The image on the left I captured in Hawaii has a reflection that is nearly equal on all sides. Yogi, on the other hand, is shaped more like an old Indian arrowhead. So what is it that gives Yogi this odd slant on the universe? To answer that, let's look at this from the camera's point of view. When I took this picture in Hawaii, my camera was pointed level with the horizon. On the other hand, when our image data shows us that Yogi has an arrowhead shape, it is because the camera is in a fixed position tilted downwards. And remember, Turrialba is an active volcano that's venting toxic gases, so the public is not allowed access. Nonetheless, using available image data, we approximated the location of the camera on the taller eastern rim of the volcano, where it is permanently mounted with a downward tilted view to the west. It was this unique angle of view and elevation that makes Volcan a true one-of-a-kind marvel. At nearly 11,000 feet, Volcan certainly has a unique view of the horizon. On the other hand, the horizon for San Jose, Costa Rica is line of sight across the nap of the Earth. The result is that as the sun is setting in San Jose, things are just starting to pick up for the Volcan feed. The result is that about the time some folks are sitting down to an early meal in San Jose, the Volcan feed is starting to become simply spectacular. So at this time, I would like to publicly thank the people of Costa Rica and their institutions for providing us a 24/7 raw video feed that is unedited and given direct to the world. Especially since it is the only one we could find in the central latitudes. All the rest point their cameras into the volcanoes or to the east. This is just another reason why the Volcan feed is truly one of a kind. But you never know. Granted, Costa Rica is situated on the 10th latitude, which of course, in terms of land masses, is pretty slim pickings. But that being said, I nonetheless am making an appeal to the good people of Caracas, Venezuela, and Ho Chi Minh City, Vietnam. You too are on the 10th parallel, so hey, if Bluebonnet turns up in your neck of the woods, please do let us know by dropping us a line. In the meantime, we've come to the point where we're left with one last piece to this puzzle. So let's cover what we do know. We know that Volcan is a high-definition surveillance camera with a powerful lens. And we know that the arrowhead shape of Yogi confirms that Volcan is tilted downwards, looking out to the west. So the last piece of the puzzle is Yogi's rubble-like texture. Where does it come from? In answering that question, let's first remember that this is an outdoor surveillance camera, which means it has to operate 24/7 in a highly corrosive and dirty environment. This is why the camera will likely have been installed inside a weather-resistant aluminum housing such as the one shown. The housing itself has a lens shield, which sits in front of the camera lens, so as to provide a safe, sealed environment for the camera. Consequently, the rubble-like texture we see with Yogi is literally the result of a dirty lens shield. So what our analysis of Yogi has yielded is further corroboration for Bluebonnet as a real object. Now, some of you might be wondering, is Bluebonnet a comet? We see it in the news with ISON and Pan-STARRS. Well, these comets are nowhere near the field of view. That brings us to another question. Could we be looking at a planet, such as Venus? Well, we're going to look at that, and then there's one more option. Is it a harbinger of doom object predicted by Nostradamus? And if it is, where is it going? In October 2007, the History Channel aired The Lost Book of Nostradamus, in which 7 prophetic images paint a catastrophic end to life as we know it. Most are already familiar with the fact that Nostradamus uses the 12 signs of the zodiac extensively in any of the work that he does. However, in this lost book prophecy, Nostradamus tells us that the constellation Ophiuchus plays a pivotal role, and that is of concern here. This is because the Volcan feed image data shows Bluebonnet transiting through or very near to the constellations Ophiuchus and Sagittarius. Ophiuchus, the serpent bearer, was once the 13th sign of the zodiac. There are no stars of particular note in Ophiuchus, but when we look at the serpent bearer's feet, we find the key to our mystery. It's called the ecliptic, and Ophiuchus straddles it on both sides, north and south of the ecliptic. To help us understand this in terms of Vulcan's view to the west from the higher eastern rim of the volcano, let's begin with a look-down view of the 12 constellations of the zodiac as we know them today. At the center of the zodiac is our Sun, and here we are looking down on our solar system from the northern skies directly above good old Sol. This view of the solar system is quite familiar to most people because this is how we usually see it for the first time in an elementary school textbook. But here we see it much like we do in our astrological forecasts in the Sunday paper. However, one serious drawback to this view of the system: there's really no way to know how far south goes south. So, to give us a convenient dividing line between north and south, astronomers use something called the ecliptic, an imaginary plane that emanates outwards from the center of the Sun, through our solar system, and out beyond the 12 constellations of the zodiac. To fully appreciate the ecliptic, we need to change our look-down point of view to one in which we are looking edge-on to the ecliptic. Now, back to the question of could Bluebonnet be a planet like Mercury, Venus, or Mars? To answer that, let's zoom in to a view of the ecliptic as seen from Earth, to see where the major planets in our solar system orbit the Sun. Here we see the four inner planets: Mars, Earth, Venus, and Mercury. Like the outer planets, Jupiter, Saturn, Uranus, and Neptune, all of these planets orbit the Sun directly on or very close to the ecliptic. Consequently, their orbits are so stable, it's easy for us to know where to find them anytime we choose. With this in mind, let's return to our previous view of the ecliptic from directly above the Sun. Here we see the 12 constellations of the zodiac, the Sun, and the imaginary plane we call the ecliptic. So where in all of this do we find Ophiuchus? When looking down on our solar system from above, we see Ophiuchus nestled in between Sagittarius and Scorpio. Now let's return to our head-on view of the ecliptic. If we are to find Ophiuchus on the ecliptic, where do we begin looking? A common assumption folks often make is that the ecliptic is the same as the horizon we see from our own backyard at night. What this simple assumption does not take into account is that our planet is tilted on its axis and has a little bit of a wobble. Consequently, the ecliptic is continually changing when viewed from Earth. But when we use a popular sky program to see where the ecliptic is in relationship to the horizon, we see something more like this, where the green line moving through the center of the image is the ecliptic, and the white line cutting across it is the actual horizon as seen from the point of view of the camera. Here we see it on December 1, 2012 from the point of view of Volcan in Costa Rica, and then again on December 17th, just to give you an idea of how the Sun transits Ophiuchus. This now brings us to a thorny possibility. Could Bluebonnet actually be the Ophiuchus harbinger of doom predicted by Nostradamus? Nostradamus is interesting reading, but unfortunately with Nostradamus there's always controversy and there's always debate. We never really wanted to step into all of that because our guiding principle in this research effort is very simple. Believe nothing. Observe everything. Now we'll show you what we have observed with regards to Bluebonnet's position relative to the ecliptic during the month of July 2013. In this sequence, we're going to show you a comparison between the Volcan feed and what we were seeing with Starry Night for that same point of view at that same time. Then we'll combine them together to give you a rough feel for Bluebonnet, the ecliptic, and the horizon. To do that, we use a green line to represent the ecliptic and a red line to represent the horizon. Consequently, it is easy to see that Bluebonnet is not orbiting our Sun like any of the cataloged planets in our solar system. Rather, Bluebonnet is clearly moving north of the ecliptic. And that is where we always found it during the month of January 2013. Naturally, this made us wonder, could Volcan have also imaged Bluebonnet sometime last year, south of the ecliptic? Many webcam pages will offer an archive, so you can go back and look at old images. With Volcan, now it's just a raw feed, there's no archive, and it would be nice because we could have gone back into the archive to see if Bluebonnet was showing up in 2012, but no luck there. However, Barbara, knowing that this was a hot button issue for me, went out there and combed the waterfront, as they say, and she turned up something pretty darn interesting. On April 16, 2012, Wired.com blogger Eric Clementi posted a Volcan image capture. The timestamp on the capture is for April 15th at 5:25 Central Standard Time. That is the standard time for Costa Rica down there. This timestamp is important to note because earlier in the program we viewed motion studies for this same time of day. Ergo, we know it would have been possible to view Bluebonnet during this time. But where? Well, we found what could be a possible candidate for Bluebonnet. By comparing that with Starry Night, we see the same alignment with the horizon. And there, at the 8 o'clock position, we see an object. While it is to the left of the sun as we look out over the horizon, it is clearly well below the ecliptic in this Volcan image. So have we seen any other mystery objects on this side of the sun? Yes, in our article, Countdown to Planet X, published last November, we documented 2 sun sightings by airline passengers at altitude, one in Australia and another in Japan. In both cases, civilian airline passengers made naked eye observations of what appeared to be 2 suns in the sky. In both cases, they were flying at dusk. Richard Shaw of Pinlight Productions worked closely with me on both the analysis and the interviews. While neither report could be authenticated, Richard nonetheless found something of interest. While analyzing smartphone video captured in Australia on July 3, 2012, Richard found an unidentified natural object very close to the sun's 9 o'clock position. We named it the pimple. When it comes to debunking imagery, Richard Shaw can leap tall buildings in a single bound. So when he says something is a natural object, you might just want to take note of that. So with that in mind, let's compare this April 15, 2012 observation with one taken on January 27th of this year. Also note that these images were captured by different people months and hours apart from each other. Nonetheless, it is clear to see that Bluebonnet is well above the ecliptic, the green line running along the left-hand side of the screen. Consequently, if it were Venus, it would be tracking directly along that green line. So now let's return to a side view of the ecliptic where we see the southern skies below and the northern skies above. Yet, this is not how the Volcan camera in Costa Rica sees it. Rather, here are the southern skies for Volcan in this study, and likewise, here are the northern skies. So now we're ready to compare our 2 images from 2012 and 2013. Assuming the April 15, 2012 Volcan feed image published by Wired magazine places Bluebonnet at the 8 o'clock position near the sun, then what we have is an object that has moved up from the southern skies into the northern skies near our sun. Also note that our team continues to download Volcan images, and what we're seeing in early February is a continuation of Bluebonnet's northward trek from the ecliptic. Well, there it is, folks. That's the story, at least as much as we have up to now. Now, remember, this volcano is active, and so nobody can go up to the top, which means no boots on the ground observation. So what I have is a very compelling single source, but not a situation where I can say with absolute certainty exactly what Bluebonnet is. So you're going to have to do that yourself. And I hope you'll join with us in continuing the search for this data. But in the meantime, I see one of three possibilities moving forward. The first is that the Volcan feed mysteriously and suddenly becomes unsuitable for our purposes. If that happens, what will that say about this? The second is that, well, all bluebonnets eventually fade away. And I would love nothing more than to see this bluebonnet do the same. And then we have the third possibility, the one that, well, pulls on the Nostradamus string, if you will. Could it be we've yet to see Bluebonnet come into full bloom? And I'll leave it on that note. So until the next time we meet, remember Marshall's motto: destiny comes to those who listen and fate finds the rest. So learn what you can learn, do what you can do, and never give up hope. This is Marshall, and I'll catch you on the backside.